Moving forward with nomenclature, let's talk about polyatomic ions. Uh, if you're not familiar with this term, if we break apart the different sections of the name here, it should make sense what we're talking about. So poly, if you're unfamiliar with this prefix, I believe it comes from the Greek, and essentially it means many. So polymers, for example, it comes from the same root there. A polymer is a very, very large molecule. It's lots and lots of atoms all bonded together. And so here we have polyatomic ions. And so what this means is that we're looking at ions that are made up of more than one atom. We don't have to have many atoms in this case. Just as long as we have more than one, we consider it a polyatomic ion. So in the previous video, when we were looking at these here, each of the ions was just a single element. We might have more than one of that element, but it was always just one metal and one nonmetal. And here, we are now going to have multiple nonmetals making up our anions. Now, we technically will also have one cation that is a polyatomic ion, but the vast, vast majority of them are anions. So these groups of nonmetals that stick together to form an ion are called polyatomic ions, and they don't usually break apart from each other even when chemical reactions are occurring. Now sometimes they do. It's not rare even, but most of the time they do stick together. So even when a chemical reaction occurs, if you have a nitrate or a nitrite like we have here on the reactant side, usually it's still going to be there on the product side of the reaction. They tend to stay together because they're relatively stable usually, and they don't break apart. So when we're naming these, I have good news for you. We don't really have a system for these for the most part. There are a few things that you could call a system that help you differentiate from one ion to another, but even with those systems, I'm not going to expect you to memorize the names of ions. We are just going to have a list that we can reference, and so as long as you can find it on the list, you are good to go. You don't have to memorize that NO2 minus is nitrite. If you see you have NO2 minus, then you can just go to the list and find it there and say, oh, it's nitrite. The other nice thing about these is that when we are naming the molecules that have polyatomic ions in them, we have no special rules. So we're not actually adding any rules on for these polyatomic ions. So if, for example, we have an ionic compound that has sodium metal and the polyatomic ion nitrite, the name of that molecule is just sodium nitrite. It's just the name of the metal and the name of the polyatomic anion. No changing the ending, no putting in prefixes, no nothing. It is just the name of the metal, the name of the group, that polyatomic ion. So here is one example of the list that I was mentioning to you. This has the most common ones, but there are definitely others that aren't listed here that you might come across every once in a while. But these are by far the most common that you see here. And you can also see the one cation that we will see, which is the ammonium ion. But all the rest of these are anions, which is to say all the rest of these have negative charges. All right. You might have noticed on the previous slide there when we were looking at all the different anions that nearly all of them, I think actually the only exceptions on here are this one and this one, nearly all of them have oxygen as if not the most significant part. at least a significant part of the ion. And this is something that's very common. And because it's so common, we actually give them a special name. These are what we call oxyanions. So oxyanions are polyatomic ions that have oxygen in them. And these usually, well, no, I shouldn't say usually, but quite often these oxyanions will come in series. And what I mean by that is you will have multiple polyatomic ions where the only difference from one ion to another is the number of oxygens in the ion. So, for example, there is a nitrogen oxyanion series that contains nitrate and nitrite. The only difference between these two is the number of oxygens. Both of them have just one nitrogen. Both of them have just a single negative charge. The only difference is that this one has 3 oxygens and this one has 2. That is the only difference. Similarly here with the sulfur series, we have sulfate, which has 4 oxygens, and sulfite, which has 3. And that is the only difference between those two. Inside of these series, we do have a little bit of a naming convention that you should remember, but again, you're always going to have that list. So even if you can't remember off the top of your head what the rules are here, you can always just go to the list and find these on the list, and you can figure out what the convention is. But the naming convention here is that if you only have 2 ions in a series, the one that has more oxygens, the name will end in ate, and the one that has fewer oxygens, the name will end in ite. So this is what we saw with nitrate and nitrite, and sulfate and sulfite. The one that had more oxygens ended in ate, the one with fewer ended in ite. Now notice I'm saying more and fewer. I'm not saying the one that has 4 oxygens ends in ate and the one that has 3 oxygens ends in ite, because it's different over here. Here, we have 3 and 2, not 4 and 3. So it's not tied to a number, it's just tied to which one has more, which one has less. If you have a larger series, like we have here with the chlorine and the bromine, then we add on a prefix. So we still keep the ite and the ate for more or less, more or fewer oxygens. If we have the most number of oxygens, that would be per chlorate. And if you have the least number of oxygens, it would be hypo, and then in this case it's chlorite. But over here we have bromite. The key thing there is just that it ends in ite. So again, there's a little bit of a naming convention there that I do expect you to remember that, but again, you don't necessarily have to memorize it, because like I said, you will have a list similar to this one, and so if you're like, I can't remember, what are the rules for that? You can always just go to here and look, oh, there's the chlorines. 1, 2, 3, and 4 chlorines, hypo, chlorite, chlorite, chlorate, perchlorate, and so you can just see the convention there. So I do expect you to know it, but I'm essentially giving it to you as well. Alright, so let's name a few more molecules here. I think we'll do these 2 slides, yeah, and then we'll call it for this video. So this particular slide here is kind of a mixture of multiple different ones that we've seen. Everything here does have a polyatomic ion, but actually everything here, we don't have any transition metals, so we don't have to worry about the Roman numerals for these. But that will sometimes happen. I think that'll be, yeah, so here on the next page we'll have some with Roman numerals. But for these, to name these, once again, you're just going to take the name of the metal and then the name of the polyatomic ion. So I'll do the first 3 here with you, and then I'll let you practice with the next ones. So the first one here is just given to us. We have sodium, and then this is carbonate. And obviously you probably don't know that off the top of your head, but if you go back to the list, there it is, CO3, and it has a 2- charge, which is why we needed 2 sodiums here to balance out the charge. And so it's just sodium carbonate. The next one here, we have potassium, and then PO4 3-, and I know it's 3- because I needed 3 potassiums, which are each +1. If you go back to the list, that is phosphate, right there, PO4. And so this is potassium phosphate. No need to add anything on to the end, no need for Roman numerals, just potassium phosphate. So then the last one here I'm going to do with you, we have barium. Barium is in column 2, so we don't need Roman numerals for it. And then NO3, and that is NO3-, and I know that because barium in the second column is +2. I have 2 of these ions, which means each of them must be -1 for the overall charge to end up being 0. If I go to the table, NO3- is nitrate. So this is barium nitrate. So go ahead and try these last ones here. And actually, before you do that, let me work the first one that's written out, and then you can do the second and third one. So this is lithium chromate. So we're asked to draw the molecular formula for these last 3 here. So we know we have lithium, and chromate, if you go back to these table here, let's see, where's chromate? There it is. CrO4, 2-. So I have CrO4, and this has a charge of 2-. Lithium has a charge of +1. And I'm just writing these up here just so you can see it. You wouldn't actually normally write them there. That's just there for your benefit. Because I need 0 as the charge of the whole thing, I'm going to have Li2CrO4. I need 2 lithiums to balance out the charge of the 1 chromate. All right, so give these 4 here a try. Try to write out the names for these 2 and write out the formulas for those 2. So go ahead and pause the video now. Okay. Hopefully you gave that a try. Let's see if you got the right answer. So this one, we have potassium again. MnO4 is what we call permanganate. And I think I'm spelling that right. Spelling has never been my strong suit, but I believe I am spelling permanganate correct. And if you happen to notice that the structure here is wrong, bonus points to you, and those are bonus points like on the whose line it is it anyway. I won't actually go into the grade book and give you bonus points, but in your bind you can have bonus points because that actually has the wrong structure. Permanganate. Oh, actually, no, it doesn't. I'm just misremembering, apparently. Never mind. Forget I said anything. This is what happens when I make videos in the evening. I always end up having making mistakes like that, but oh well. So for some reason I was thinking that permanganate was a -2 charge, which would mean that I needed 2 potassiums, but I was just misremembering that. Permanganate does just have a single negative charge. So that is the correct structure. So it is just potassium permanganate. So then for this next one here, we have our one and only cation. That is a polyatomic ion. So this is ammonium, and this is sulfite. SO3, 2- is sulfite. strontium perchlorate is going to be this. So if you just have SrClO4, what you're forgetting is that strontium is +2 and the perchlorate is only -1. So you need 2 of those to balance out the charge. Sodium phosphate is our last one, and that is going to be Na3PO4. Because phosphate is -3, each sodium can only be +1, so we need 3 of those sodiums. Alright, so then the last little bit here for this video, we're going to give the formulas once again, but these are a little bit more complicated because now we're throwing in a few, not all of these, but a couple of these have the Roman numerals with the charge. So I think I'll do this one and this one with you, and I'll let you do the other ones. So sodium perchlorate, I've already seen both of these actually, but not together. Sodium perchlorate would be NaClO4. Perchlorate has a -1 charge, which means we just need one of it to balance out the positive charge on the sodium. And so for this one here, iron 3 bromide, we know we're going to have iron, and we know we're going to have bromine. Now notice here, one thing I do want to point out, we don't have iron 3 bromate. This is a very common mistake, is students will read this and go to the list looking for bromate, because it's on here. At least I believe it is. Where is it? I guess it's not on this list, but we had it here. So we had bromate here. Bromate and bromite and bromide are 3 different things. I know it's confusing. All the names are very, very similar. But bromite with a T is this. Bromide with a D, that just means you have bromine. It's just a plain old bromine. And so because we have iron 3, that means the iron has a charge of +3. Each bromine is -1, which means we need 3 of those. So that would be iron 3 bromide. Alright, give those last 3 a try, and then we will call it for this video. So pause the video now and try to work those out. Alright, so for this first one here, strontium and nitrate. Strontium is +2, it's in the second column. Nitrate is -1, so we need 2 nitrates to balance out the charge on the strontium to give us a 0 net charge. Similarly down here with tin and oxygen, we need a net 0 charge. If tin is has a +4 charge, then we're going to need 2 oxygens, because each oxygen is going to be -2, since it's in column 16. And then lastly here, ammonium, which has a charge of +1, which means we would need 2 ammoniums to balance out the -2 charge on sulfide. And again, sulfide with a D, that is just sulfur. Sulfite with a T would be that. So that is sulfite. So you need to be paying very close attention to the way that the word is spelled, because you have 2 different things that are very, very similar, just 1 letter difference in the name, and it is a completely different thing. So you'll be paying very close attention. Alright, we'll leave it there for this video. In the next one we'll talk about naming molecular compounds. These are compounds that only contain nonmetals. So I'll see you there.